Welcome back to The Explainer. Today, we're taking on a seriously fascinating journey. We're going to trace how invisible greenhouse gases transform into a highly structured, highly valuable global financial asset. We're mapping out the entire ecosystem here, from the absolute basics all the way to complex trading floors, to uncover how managing this invisible gas is rapidly becoming the ultimate driver of our future economy. Right off the bat, think about this wild paradox for a second. Practically every single thing we do, whether it's driving a car, flipping on a light switch, or running a massive manufacturing plant, produces an invisible exhaust. And because it just floats up and away, it's incredibly easy to ignore, right? But that invisible exhaust from our daily commutes and supply chains is literally the fuel creating a brand new, multi-billion-dollar global economy. We're watching an entire financial system being built on something you can't even see. Okay, let's dive into this. Here is our specific roadmap for decoding this massive global system step by step. We're going to start by defining the carbon problem, then we'll break down the math of the net zero equation. After that, we'll cover strategies for carbon reduction, take a look inside the carbon market, and finally, look ahead to the future carbon economy. All right, kicking things off with Section 1, defining the carbon problem. To truly understand these massive global markets, we first have to zoom all the way into the micro level. We need to look at the everyday human activities that actually create the problem. And it all begins with one fundamental concept you've probably heard of: the carbon footprint. Whether you're a single person, a giant multinational tech company, or an entire country, your carbon footprint is the total amount of emissions you produce. It's the ultimate measurement of your climate impact. Now, to calculate this, organizations use something called an emission factor. For example, burning 1 gallon of gasoline equates to roughly 20 pounds of carbon dioxide. So an emission factor basically takes your raw activity, miles driven, power consumed, and translates it into a uniform, measurable carbon weight that we can actually track. To make this a bit more tangible, let's look at how everyday choices alter the size of that footprint. Take a flight, for example. That has an incredibly high carbon impact just because of the sheer volume of jet fuel required to keep thousands of pounds up in the air. Driving your standard gas-powered car, that sits right in the medium range. But hopping on a bicycle yields absolutely zero emissions. When you start compounding those individual choices over a week, a year, or across a company of 10,000 employees, well, you can begin to see how wildly footprints can fluctuate based on our behavior. The physical flow of this problem is basically a direct chain reaction. Your human activity creates CO2 emissions. Those emissions go up into the atmosphere, and while carbon dioxide is entirely natural, the catch is that human industry has just pumped way too much of it up there at an unprecedented speed. That excess CO2 acts like a giant, invisible blanket, trapping solar heat that would normally bounce right back into space. And that trapped heat directly leads to global warming and climate change. It is an unbroken physical chain reaction from a car's tailpipe all the way up to a warming planet.
Which brings us to Section 2, the net zero equation.
Now, what's really interesting about this slide is how it takes a massively complex global goal and simplifies it into basic math. This is the entire concept of net zero in a nutshell. You take your total emissions, subtract your total reductions, subtract any offsets, and you have to equal exactly zero. It's an absolute balancing act. We have to perfectly balance what we emit into the sky with what we stop emitting or physically remove. And the reality, this math is extraordinarily difficult in practice. We simply can't stop all emissions tomorrow without modern society completely grinding to a halt, We have to keep operating while simultaneously fixing the equation. Moving right along to Section 3, strategies for carbon reduction. So how do we actually change the numbers in that equation? We transition from an abstract mathematical formula to actionable steps. This right here is the carbon management pyramid, and it works as a strict 4-step hierarchy. Step 1, avoid emissions entirely. Step 2, reduce the emissions you absolutely can't avoid. Step 3, replace your existing power with clean energy. And finally, Step 4, and this is only after you've heavily invested in the first 3, offset your remaining carbon. It's super tempting for organizations to just jump straight to Step 4, because buying offsets is way easier than completely redesigning a massive supply chain. But notice how offsetting is at the very bottom. You cannot truly manage a carbon footprint without doing the hard, foundational work of avoiding and reducing first. Building directly on that pyramid, when we look at the true effectiveness of our actions, reduction is categorized as the absolute best strategy. It has the highest impact, no question. Reusing is medium, and offsetting, that's merely supportive. It's a safety net. Offsetting doesn't stop the root cause of the emissions from happening, it just attempts to clean up the mess afterward. And that's exactly why reduction is always prioritized as the gold standard of corporate sustainability. Okay, so how do companies actually execute those top tiers of reduce and replace? They deploy tangible, real-world methods. They might switch a factory's power supply to renewable energy or drastically boost energy efficiency through smart grids. They invest heavily in sustainable transport and green buildings. But when it comes to the trickier, heavy industrial emissions, like steel or cement manufacturing, they have to lean on advanced emerging tech like direct air capture or industrial capture. Think about trying to extract a few drops of ink that have been stirred into an Olympic-sized swimming pool. That's essentially what direct air capture has to do with CO2 in the atmosphere. It literally vacuums the sky to pull the carbon back out. It's incredibly difficult, highly expensive, and right on the cutting edge of modern engineering. But what if a factory does all of this, invests millions, and simply cannot reduce all its emissions? That brings us to Section 4, inside the carbon market. Before anyone can trade anything, we need a baseline metric. Everything in the carbon market revolves around one baseline measurement, 1 ton of CO2. That is our universal unit of account. To give you a mental image, if you captured 1 ton of carbon dioxide gas at standard atmospheric pressure, it would completely fill a 2-story house or a massive hot air balloon. That single standardized measurement anchors the entire global market. So the crucial point is, how do we transform that one massive balloon of gas into a financial instrument? We do it through the carbon credit. A carbon credit is, quite literally, a permission slip to emit exactly 1 ton of CO2. It successfully turns an invisible, floating gas into a highly specific, strictly regulated, tradable asset with a real-time monetary value. Let's trace the life cycle of one of these credits. Say an organization starts an emission project, like reforesting a huge area of degraded land, or maybe building a massive wind farm. That project creates a measurable carbon reduction. But here is where the absolute most critical step happens: verification. Without strict, independent auditors, the whole system just falls apart into greenwashing. A company can't just claim they planted 1 million trees. Third-party auditors have to scientifically verify that the trees are actually in the ground, surviving, and actively drawing down carbon. Only after that strict verification is a credit issued. And finally, that credit is taken to the market to trade. It's a whole narrative. A tree grows, carbon is captured, a credit is born, and a company buys it to balance out their net zero equation. When those credits actually go to market, they enter one of 2 main arenas. First, we have the compliance market, which is strictly regulated by governments. Here, heavy polluting companies are legally forced to buy credits if they go over government-mandated emission limits. If they don't, they face massive financial penalties. Then, on the flip side, we have the voluntary market, which is largely driven by the private sector. This is where tech giants or consumer brands buy credits based on corporate goodwill, public relations, and their own internal sustainability goals, not necessarily because the law is forcing them to. Let's wrap things up with Section 5, the future carbon economy. Let's zoom out from the individual credits for a second and look at the global perspective. How are these markets actually reshaping international policy? Well, based on the Paris Agreement, different regions are committing to net zero on vastly different timelines. And this brilliantly illustrates the challenge. The European Union is heavily industrialized and targeting net zero by 2050. Meanwhile, rapidly developing economies like India, which still need to build massive amounts of infrastructure just to raise basic living standards, are targeting 2070. The global rules of trade are being written right now. Navigating a world where different economies are moving at entirely different speeds toward that zero balance equation is creating some profound diplomatic and economic challenges. But because of these massive tectonic shifts, entirely new industries are emerging practically overnight. The flow of carbon data turning into credits in trading is birthing highly profitable sectors. We're talking about the carbon trading business, ESG consulting, and the incredibly fast-booming world of climate finance. This isn't just some niche environmental field anymore. If you're starting a career, running a business, or looking at long-term investments, carbon accounting is rapidly becoming as standard and as legally necessary as traditional financial accounting. I really want to highlight this powerful prediction directly from our source material. Companies will compete on carbon efficiency, and governments will impose strict limits. Just think about what that really means for a second. If 2 companies manufacture the exact same product, the company with the lower carbon emissions is going to face significantly lower regulatory costs. That makes them naturally more profitable and way more competitive. Carbon management is no longer an optional PR exercise. It's a fundamental requirement for business survival in the 21st century. So, what does this all mean for us? I want to leave you with this final, provocative question to chew on. Will carbon become the next global currency? When you realize that every single ton of CO2 is being meticulously measured, independently verified, and traded across international borders exactly like a stock or a bond, it's absolutely fascinating to consider that managing our carbon footprint is rapidly becoming the very foundation of global finance. Thank you so much for diving into this with me today. Keep exploring, keep questioning, and I'll see you in the next explainer.